Dynamic occlusion is already here. Well, kind of. We're going to talk about it in a moment. And it's incredible. Basically, hiding virtual content behind real-world objects. You have to see this. Hi everybody, in this video I have an incredible thing to share with you. Now, if you play on the Quest 3 or if you don't know it yet, you still want to hear that. So basically when I played First Encounters, this is the first game that I played with mixed reality on the Quest 3, I noticed that when my hands, real hands, are always appearing behind virtual content. This means that, again, if it's a virtual content itself, like the guns, you're going to see them on top of everything. But if my hands, real hands, are there, they're going to appear always behind the virtual content. The reason for that, well, there are two separate layers. So because the virtual content is always on top, this is why your hands and even your body appears always behind the virtual content. And you can see it right here. I'm seeing in slow motion. Look at my right hand. You see, the gun is on top, but my right hand, my physical hand, is below the virtual content. Take a look again on the right side. It's hidden behind the part that is virtual. Now, the game itself was designed well to kind of counter it. Usually, again, when you play a shooter game, your hands are usually down, and design the cracks in the wall so they won't appear really until the floor. So basically, you won't really notice it. You can see it here as well in Figma and XR. When I move my hand, you see it will always be below the virtual content. Now, some apps of course solve it by just replacing your hand with another virtual hand or putting a semi-transparent glove-like so it actually shows your hand movement, especially when you're using hand tracking. By that I mean using your own hands in order to interact with content. But there is a new thing, official from Meta, called Depth API. It is experimental, but I'm going to show it to you and it's incredible. Now I'm going to quote, Depth API is a new feature that exposes the application real-time, per eye, per frame, environment depth estimates from the headset point of view. They also mentioned that Depth API can be used to implement dynamic occlusions. This technique is essential for rendering believable visual interactions between virtual and physical content in your apps. This enables a more coherent sense of reality for your users. Now, aside from you need an app that actually uses it, in order to use it on the headset, you need to run this ADB command to enable experimental features. And Meta shares some project on GitHub, although I needed to, again, download Unity and also add a certain camera and other kind of changes to make it work in mixed reality, because by default it was for Windows. I also learned again, and this answers some of my questions, the developers need to choose between using planes or the reconstructed, the depth scanning. They can use them both, based on my understanding. And the other thing is they need to decide whether the video layer will be on top of the virtual content or vice versa. So if you still don't understand, basically this means dynamic occlusion, and I will explain. Before that, when I actually used to scan the environment, I did it before the app, before using an app, and just once, and can reload in other apps. It just remembered the depth of scan of the room and use it in other apps. However, if I move a table, for example, during the use of the app, it won't actually update the mesh automatically. This one does, and not just that, it actually, if you can see here, it actually also scans not just the environment, but also my hands. Now, there's different options here to show you. You can see that my hands right now are actually above the virtual content. There are different options here: soft occlusion, hard occlusion, or no occlusion. With hard occlusion, you're going to see kind of more LES, not really accurate edges around my hands. You can actually see it now. And after that, you're going to see it when I'm changed to soft occlusion, it's going to be much smoother. And the thing is that soft occlusion, because it's more accurate, it requires more processing power, of course, using more of the GPU. So you can see here that this is a hard occlusion. We're going to change it. By the way, here just different guitars, no occlusion, hard occlusion, and soft occlusion. So if you thought about, well, let's see how it is like playing a guitar, you can see now you can. I mean, not play guitar, but you can actually have something more realistic, like you're holding a guitar and your hands can be on top of the guitar. Before that, your hands will be, all of the hands will be underneath any virtual content. Now, Meta also mentioned in this particular project that hard occlusion is cheaper to compute, but has a jagged edge and more visible temporal instability. Soft occlusion is visually more appealing, but requires more CPU. Here you can see I'm moving my hand around the torch, above it now. See, my hands now is on top. Again, this is with soft occlusion. I put the controller aside. You can see that even if it's soft occlusion is far from being perfect, but so much better than, especially by the way, if you're using hand tracking and just your hands, this is even more important there, because with some games you can replace your hands with some virtual ones or put overlay, so it's more forgiving. But with hand tracking alone, we just want to see your hands. This is just so groundbreaking. Here are more examples. I thought, by the way, that the refresh, the time it actually takes to scan is going to be, I don't know, several times, every 1 minute or something. I didn't know it's going to be like that in real time. It's crazy. You see the virtual content behind the controller. I'm going to show you some really more cool demos. Let's take the Oculus box again, of course, physical one. And you can see that I can put the torch behind it. Put it now forward and behind it. This is so cool. And I put something behind the box. Can you see it? Of course not. So there's the virtual glass there. You can see, put it, puts another virtual content behind it. And let's move it, and you can see the virtual content. Let's put it back. Again, before that, this wasn't possible. All the physical content, everything you see in the real world will always be below or on top, depends on what the developer decide, related to the virtual content. Well, now with the hands, it was maybe a bit less impressive, but here you can see it, because again, straight lines, it seems more accurate. But still, it's going to get improved, of course, for sure, with better hardware, better computing power, and better algorithms, better everything, until it's going to be like pixel perfect. You can see, of course, the table is a physical one, and put the guitar there underneath it. Before that, it wasn't possible. So yeah, this is dynamic occlusion on the Quest 3. I didn't know this feature exists, and it's amazing. Now, why developers are actually not using it? Well, as you can see, it's not perfect. The other thing, again, is computing power intensive. And the other thing is that it's still experimental. So I do hope that this will further improve and developers will eventually use it when it's out of being experimental. But yeah, this is insane. Absolutely insane. Just blow my mind away. This is so crucial for mixed reality to have this feature, and it needs to work well. I hope you enjoyed this one. Tell me what you think about this. If you have any questions, let me know in the comment section below. I'm going to test this so much more. I'm going to share with you on my channel, so make sure to subscribe. I'll see you on the next video. Cheers.